Hello and welcome to Honors Function. In this second video about function, we're going to be focusing a little bit on the domain of a function. It is a topic we introduced in the previous video. Let's take a closer look at it in this one. So let's recall the formula we have for the domain, the definition of a domain. If you are given a function y equals f of x, here is the domain of the function. Let's read it. It is the set of all the real numbers, and here you want the largest subset of the real number. You want them all, okay? So it's the largest subset of R, all the real numbers, such that f of x is a real number. F is a real valued function, okay? We want the output to be a real valued function. There will be three different criteria until we start studying trigonometry. You'll have to look at three different criteria in the expression of a function. Okay? What are they? All right. If a function has a fraction with x at the denominator, okay, x at denominator. If it has a fraction with x at the denominator, the criteria for domain is that b cannot be 0. Okay, so how do you find the domain? Well, you solve the equation. You solve the equation b equals 0 and you remove the solutions. Okay, you remove the solutions from where? From R. From R. Okay, that's how you find the domain whenever you have an expression containing a fraction and a variable at the denominator. That's the first criteria. Second criteria, the second criteria is about radical, but now we have to be careful, right? Because remember the cube root of -8, what is that? This is just -2, right? Because -2 cubed equals -8. So if you're cubing a negative number, you're going to find a negative number. So cube root, there's no problem. The fifth root of -32 is also -2. So we do not have any problem when the index of the root is odd. We do have some problem when the index is even, okay? If you look at the fourth root of -16, this is not a real number. It's a complex number, it's not the real number, just like the square root of -4 is not a real number. And because we want real output to our function, what will the criteria be when n is even? Okay, we call them even indexed root, even indexed root, radical, okay? This is the index of a radical. This is the index right here, okay? So what is the criteria? You will take the radicand and you will make it positive or equal to 0, okay? It's fine if it's equal to 0. The square root of 0 is 0, all right? So this is the second criteria. The third criteria is about log, and at this point, listen up, I do not expect you to remember anything about log except what I'm gonna cover right now. Sorry, base A right here. If you throw something inside a log, you better make sure it is positive, okay? It's got to be positive. That's the only thing I want you to know about log right now. You don't have to remember anything else, okay? So, at this point, let's practice some of the example from my notes. All right, first example. Find the domain of the following function. You have to use interval notation, all right? Interval notation. Okay, well, look at this function. Do you have a fraction? No. Do you have a radical? No. Do you have a log? No. Therefore, the domain of this function is all real numbers. So interval notation would be this, okay? Set notation would be this, all right? All real number, it means that whatever happens to x, it won't be a problem. You will not have any problem to do whatever you want to do to this x right here. In the end, you're always going to find a real number. All right? Okay. Example 3. All right, example 3. So in this case, I do have a radical. It is an even index, right? It's not written, but that means square root. It's 2 right here. So I got to make sure that my radicand, this is the radicand, okay? Radicand is 2x minus 9, I got to make sure that this is positive or equal to 0. Now be careful, guys. Very often I will see this. I will see this at the beginning of this problem. And this really makes no sense. I am going to take 0.5 if you write this, because by definition of a square root, you're looking at the output. First of all, you're looking at the output of a function right here. You're looking at the output and you're giving me a condition. This is a condition. First of all, it's a condition about the output, okay? And for the domain, you want a condition about the input. This is a condition about input, So you're really taking things upside down here. All right, so that's the first reason why this makes no sense. And the second reason is, well, by definition, a square root is always positive or equal to 0, right? It's always positive or equal to 0. So you're not saying anything here, okay? All right, so here's the condition right here. How do you solve that? Well, this is super easy. X above 9/2. Now, interval notation means that the domain of, I call it H, domain of H is 9/2 and above. Here we go. All right. Next example, example number 5. Okay, example number 5. So this one is a little bit more complicated. Let me write the set first of all. So it's a set of all the x's such that I like to see the condition. I like you to write the condition. Even if you can't solve the condition, I like you to write them. So right here, I do have a radical, right? I do have a radical, and it's even. And I also have a fraction. So therefore, I'm going to have two conditions here. I want 4 plus x to be positive or equal to 0. And I want 8x squared minus 6x minus 9 to not be 0. This is correct. I'll give you a point if you write this, or maybe half a point. I don't know. It depends how generous I feel, okay? But anyway, I like to see this because you're showing me that you understand there are two conditions. Now, you need to solve them. Now, this is very easy to solve, okay? X has to be above -4. How do you solve this one? Well, listen, just grab the equation and just solve the equation right here. All right, let's solve this equation. So I'm going to try to factor this. Hopefully it will factor, maybe. Let's see. Oops, not like that for sure. 2, all right, what do we have here? Equals 0. So I'm going to try 3 and 3, maybe. I got a 6 and a 12. Yeah, I can make a -6. I want -12 and I want +3. Here we go. That should do it, right? We got a +6 minus 12 and a -9 and a +8. Yep. So x equals -3/4, or x, drop my x equals 3/2 right here. So what's going on here? X has to be above -4, and here, if x is equal to -3/4 for 3/2, then this will be 0, so it's not going to be defined. So you don't want that to happen, all right? So let's write the domain. The domain of G is, so these two numbers are all above -4, right? So let's start. You start at -4, then you go to -3/4 right here, and this has to stay out. Then it is -3/4 to 3/2, which is also staying out, and then you just don't stop until the end right here. Here's the domain, okay? All right, next one, let's go over number 7. Number 7, so careful right here again. Oh, wow, there's a lot of things. You got two radicals, and you got one fraction, okay? One fraction. So be careful right here. Three conditions right here. All right, so the domain, oh, I don't give a name, so whatever. The domain of this function is made of all the x's such that, okay, what do you want? You want -x to be positive or equal to 0. And so how about we write and like this? Okay, this is actually the logical connector representing and. And what do you want? The other radical means that x squared minus 1 has to be positive or equal to 0. And what's a denominator? Square root of x squared minus 1 cannot be 0. Okay? Now we just gotta study these three conditions and put them together. So the first one is super easy. The first one is x has to be negative. All right, got it. X has to be negative. Second one, I know how to solve this. I mean, piece of cake, right? You're looking at the parabola. The x-intercepts are -1 and 1, right? This is x plus 1, x minus 1, right? and it's concave up right here. So the second condition means that x is, well, let me write I'm not going to write the interval yet. X has to be smaller than -1, or x has to be greater than 1. How would you combine this, and it's an and, right, and this? Well, if you combine them both, that means that x has to be smaller than -1. That's what it means, right? How can you be negative? So look, if you don't see this, just draw a line here. Here's the first one. The first one is telling me, hey, I gotta be right here. How about the second one? The second one is telling me, all right, I have to be below -1 or above 1. And it's an and, right? And means it's both of them at the same time. So this is it. This is below -1, right? Okay, got it. Now, let's try to understand this one. This cannot be 0, so that means that x squared minus 1 cannot be 0, okay? Because if it is, then the radical is 0, and that's the only possibility. So x cannot be plus or minus 1. Okay, so we're almost there. This is good, and I have to avoid x equals -1. So here's my domain. The domain is anything below -1. That's it, okay? Is it clear? All right. Let's talk about something I've mentioned yesterday now. Let's talk about equality of two functions. Okay, let's look at these two functions right here. Well, right away, I see that algebraically, I can do this, right? This is x plus 1 over x minus 1 divided by x minus 1. Therefore, algebraically, I can do this, and I have x plus 1. And h of x is also x plus 1, okay? So the functions have the same expression. You remember the word for expression, we call that the rule of assignment. So it's the same rule of assignment. It's the same rule of assignment algebraically, but not in terms of function. And when I say rule of assignment, I do mean function, okay? So you do have an equality algebraic between x squared minus 1 over x minus 1 and x plus 1, but not in terms of function. Why? Because a function is made of 3 objects. You remember, I stressed that yesterday. You need a domain, you need a range, and you need a rule of assignment. So right now, you have the equality of the rule of assignment. What is it that is not equal? The domain of the function. Therefore, we cannot write that the function f is actually not equal to the function h, okay? I do have f of x equals h of x. I do have f of x equals h of x because that's a rule of assignment. And whenever that's defined, they are equal. But the two functions are not equal because a function is 3 objects, okay? And the domains are different. The domain of f, I'm going to use set notation right here. It's all real number except 1. The domain of g, sorry, I call it h. The domain of h is, well, it's defined everywhere. It's all real number, right? So what's going on here? Well, the problem is that f, if you put 1 inside f, it doesn't know what to do with it. It's not going to do anything with it. If you put 1 inside h, it's going to spit back 2, okay? Let's look at the graph right here quickly. I know how to graph x plus 1. It goes like this. So this is a graph of y equals h of x. That's a graph of y equals h of x. What's a graph of f of x? Well, it's the same everywhere except when x is equal to 1, right here at 1, because at 1, f is not defined. So the graph of h is this one right here. Okay, it's the same as this one right here, okay? It's the same line, but here I will have a hole. There is a hole at 1, and I know what the output is right here. It is 2, okay? Okay, let's look at one more example and we are done with this set of notes. Okay, I will do example 10, I will let you do example 9 and 11 and all of the other ones I haven't done, okay? So, are the function f and g the same function? Justify your answer. Well, let's see. I know that normally when everything is well defined, the square root of a ratio is the ratio of the square roots, right? When everything is well defined. Now, what's going on here? What is the domain of f? What is the domain of f? Well, f is square root of something, so I need to take okay, let me write it with the set notation right here. All the x's such that x plus 3 over x minus 2 is positive or equal to 0. All right. What is the domain of g? The domain of g is made of all the x's such that, well, I have two radicals and I have a fraction right here, right? Oh, yes, I need to add right here, sorry. I forgot my fraction. And x minus 2 cannot be 0. Sorry about that. So domain of g is, let me take it this way, like that. Domain of g is, you must have x plus 3 positive or equal to 0, and you must have x minus 2 positive or equal to 0, and you must have square root of x minus 2 not 0. All right, let's look at this one quickly. That means that x has to be above negative 3, and x has to be above 2, and x has to be different than 2 right here. So let's look at all these ends, okay? You got to be above negative 3 right here. You also have to be above 2 right here. And you cannot be 2 like that. So what's your solution? What's a domain? Well, the domain is all above, sorry, negative 2 I meant. Wait, this is plus 2, sorry. This is a plus 2 right here, right? So the domain of this function is 2 and above, right? Okay, now let's look at the domain of this function. This is a sine of a ratio, so you're going to see me do that a lot. The sine of a ratio is exactly the same as the sine of a product, right? So the sine of x plus 3 divided by x minus 2 is going to be exactly the same as the sine of x plus 3 times x minus 2. And this, I know the sine of this. This is pretty simple. It's like a parabola, right? It's your parabola. It's concave up. X-intercept at negative 3 and at 2 right here. 2. Concave up. So this is positive for x smaller than negative 3 or x above 2. And right here, that means x is not equal to 2. So this inequality becomes strict. So the domain of this, so let me write it. I'm sorry, I'm squeezing everything right here. The domain of f is negative infinity to negative 3 or 2 to infinity. I remove the 2 because of this condition right here. While the domain of g is just to infinity. And so they have different domains. So the functions f is not equal to g. All right. I hope it's clear. Thank you for watching.